Alright, so the trigonometric ratios. Now, basically, a trigonometric ratio is a way that we can relate different sides of a right angle triangle, and it allows us to manipulate it a bit to find what a missing angle or an unknown angle may be, or what an unknown sine is, depending on side, in fact, depending on what information you've been given. Okay, so I've got two right angle triangles here. So let's label these. Okay, we'll call this one triangle A, B, and C, and we'll call this one D, E, and F. Okay. Now, if you've done the similarity topic, okay, I'll go through and label these, and you should be able to prove that these two triangles are similar. Now, if you haven't done that yet, that's not an issue. The point is that these two triangles are similar because all of their side lengths are within the same ratio, okay? So, why does this actually help us? Well, because the side lengths are in the same ratio, it actually means that these angles in here, so let's pick these two as our starting points, these two angles in here are actually the same, okay? And we can use what's called the trigonometric ratios to actually show that this is the same, okay? So to do so, we need to start off by labeling our triangle. Now it depends on what our angle we're picking is where we label our triangle. Okay, so we'll start off with the ABC triangle, so this one on the left here. Now, on the left, we've got the ABC triangle, and we need to label three things. So we're going to start off with the hypotenuse. Now, being in Year 10, I hope you know what the hypotenuse is, and that is the side that is actually across from the right angle. So we're going to call this the hypotenuse, okay, or just to shorthand it, just the H, okay. Now, the other two sides that we have left over are the opposite or the adjacent, depending on what your or whereabouts, what angle we're looking from. Okay. Now the hypotenuse will always be the one that's across from a right angle, but as I said, the opposite adjacent will change on the angle we're looking at. Now in this particular triangle here, the angle we're going to be referring to is the one that has this Greek letter in it. Now this is the Greek letter theta. And we're going to be using that as like our reference point. Oops. So from our reference point here, we can now find where our opposite and our adjacent are. So our opposite is the one that's straight across, okay? So it's the one that crosses over the hypotenuse arrow and is the one from the opposite side of the right angle. So here's my opposite, not a right angle, of the angle, okay? And of course we can use O as our shorthand here. And that leaves our adjacent, and adjacent meaning next to. So of course the one that's next to is the one that's down here. It's our adjacent, okay? So our adjacent down here. Now we can do the same thing for this triangle on the right hand side over here. So labeling our hypotenuse is the side that goes across here. So H for hypotenuse. Now our opposite is the side coming across here. And our adjacent is the side that is next to our unknown angle, our unknown theta angle in here. Okay. Now, there are three different trigonometric ratios that we have. Okay, so we've got the first one, which is sine, the second one, which is cosine, and the third one, which is tan. Now, these are all dependent on what angle you're using. So we've decided that we're going to be using that Greek letter theta. So we're going to be using sine theta, cos theta, and tan theta. Now, our trigonometric ratios is basically a fraction of two of the sides. Now, our sine ratio is the opposite over or divided by the hypotenuse, okay? So the opposite divided by the hypotenuse. And so to calculate our, well, we'll do this in a moment. We'll just write out what the ratios are. So sine theta is opposite over hypotenuse. Cosine theta, okay, is the adjacent over the hypotenuse. And finally, our tan theta is equal to the opposite over the adjacent, okay? So these are our three trigonometric ratios. And we can transform these into a mnemonic, just a way to remember these in case they ever come up. And this is something that you will need to remember, regardless of what level of mathematics you do. So this is the mnemonic is SOHCAHTOA, okay? And the way we read this is SOH stands for sine, opposite, hypotenuse. So sine is equal to opposite over hypotenuse. Ka is cosine, adjacent, and hypotenuse. Similarly, cosine is equal to adjacent over hypotenuse. And finally, toa, which is tan, opposite, and adjacent. And again, it's tan, opposite over adjacent. Okay. So if we come back and look at our triangles from up here, we should notice that we've got, a 3, 4, 5 triangle and our 6, 8, 10 triangle. Now, if we were to use these trigonometric ratios, and I'll just clean these up a little bit, just get rid of these arrows from the inside because it just makes it a little bit messy. Okay. So if we were to write out our trigonometric ratios, okay, using these triangles here, we should notice that we're probably going to get the same ratio, okay, because these two triangles are similar. And basically what we're saying is that the ratio between the sides are the same, okay? So let's have a look at this. So we'll start off with the sine for the first one. So this is the sine theta, and I'll write up here, so triangle ABC, and we'll do the three ratios for this particular triangle, okay? So sine theta is equal to, okay, so we'll go back up to our triangle. Now we're looking for the side that is the opposite. So this is why we should label our triangles to begin with, because now I just need to look for which side was the opposite from my angle theta. Okay. Now my side opposite was the 3. Okay, so it's going to be 3 over, and I'm looking for my hypotenuse finally. So my hypotenuse is up there, which is the 5. Okay, so it's going to be 3 over 5. And so the ratio of sine in this right angle triangle is 3/5, and that's it. Okay, so that's the ratio. And this is going to help us actually do a little bit of calculations later on. But for now, the sine ratio in this particular triangle is 3/5. Okay. Now we can do the same with cosine and with tan. In fact, I implore you to pause the video now and actually write out those ratios. Okay. So if you've done so and you've got the answers, we'll have a look in a sec to make sure. But a cosine being adjacent over hypotenuse, which is 4 over 5. Okay, so 4 over 5. And tan being opposite over adjacent, so 3 over 4. Okay, so it's going to be 3/4. Now that was for triangle ABC. Now finally we're going to do triangle DEF. Okay. And as mathematicians, we're lazy. We like to shorthand everything. So I've drawn a triangle for triangle to represent the word triangle. DEF. Okay. I'm going to do these same 3 ratios. So sine, cosine, and tan. Okay. So sine theta, again, is opposite over hypotenuse. So looking at this second triangle, the DEF triangle, so my opposite is 6, my hypotenuse is 10. So it's going to be 6 over 10. And if we were to simplify this fraction, we would actually get it to be equal to 3 over 5. Okay, which is the same as triangle ABC. And this is what I was saying about earlier about the similar triangles. Didn't have to know that they were similar triangles, but the ratios are the same because they are similar. Okay. Now using the cosine and the tan. Have a go at them. Pause the video now if you'd like to have a go. I'm sure there's many of you that wouldn't like to have a go and would just like the answer. So the answer is, of course, 8 over 10 for cosine, which simplifies to 4 over 5. Again, the same ratio as the cosine of ABC. And of course, we've got 6 over 8, which simplifies to 3 over 4 for the tan. Okay. So that's pretty much what the trigonometric ratios are. Okay, and this allows us to do a few things. Now, there are some relationships between these ratios, okay, that might come up, okay, but it's not necessary for you guys to really know just yet, but it may help you if you're thinking about doing advanced or extension 1 mathematics come year 11 or year 12. So one of these identities, we call it, so I might write this down here, so a trigonometric identity or a trig identity, okay, it's just a clever little one. Now, if you don't want to listen from this point onwards, that's fine. Okay, I'm happy for you to stop from there because all we need to know about was the ratios, and we'll talk about the we'll do some examples in the second video. But if you just want a little bit of an extra idea, then keep watching because this is a really cool little factoid. Now, tan theta, okay, can be written out as sine theta over cosine theta, okay? Now, this is a weird little consequence of what happens with our ratios. So, what I'm going to do is I'm going to show you that this works just with one example. But this does work for regardless of what any examples you have. And if you're doing, you know, extension 1 or extension 2, or advanced or extension 1 maths, this is an identity that pops up a fair bit and it's interchangeable. So, you know, if you have tan theta in a problem, you might want to swap it to sine over cos just to be able to simplify another expression, okay? So, from above, okay, we knew that sine theta was equal to 3/5. Okay, this is from triangle from above. I'll say from triangle ABC, this is. We knew that sine theta was 3/5, and we knew that cos theta was equal to 4/5, okay? Now, sine theta over cos theta, so if I rewrite this out, so I'll just move this down here. Sine theta over cos theta. Okay, well, what do we know sine theta over cos theta to be? Well, sine theta over cos theta is just another way of division. Like, we're just dividing. So we could rewrite this as sine theta divided by cos theta, okay? But we know from above, like just from that triangle ABC, that, well, sine theta was equal to 3/5 and cos theta was equal to 4/5, okay? So if we substitute those values into this, so we substitute the 3/5, put the division in there and divide that by the 4/5, okay? And we solve these fractions. So to divide the fractions, we multiply it by the reciprocal, okay? So we get this guy here. And we know from multiplying fractions that we times the tops across and we times the bottoms across. So we get, I don't know why it's up to green, but we're going to get 3 times 5, which is 15, over 5 times 4, which is 20. And this guy simplifies to 3/4. Now, 3/4, if we come back up and look at our original ratios, 3/4 was the exact same as what we had for tan. So it's just a cool little factoid that we had here. So this is the same as what tan theta was equal to. So therefore, we could say that tan theta is equal to sine theta over cos theta, okay? Which is a cool little factoid. So I hope you guys found this useful, okay? In the next video, we're going to do an example on why this is actually useful. And yeah, I hopefully, you know, you guys actually get something out of this. So thank you.